Welcome back for the lecture 2 of this week. So we had started our discussions on text summarization, and in the last lecture we discussed one of the very important approaches for text summarization, that is based on a graph based method, that is called also lexrank or PageRank method for summarization. What was the idea there? So we are taking all the different sentences in the document and then finding out the similarity between them and trying to choose and then once we run the PageRank algorithm over this graph, we take the sentences that have the high page rank. So idea is that my document corresponds to one particular theme, and the sentences that are important to this document should have many other sentences similar to that. And that was the idea that was captured by using the PageRank formulation. So the sentences should have high incoming edges from other important sentences. And then we said, okay, so this will give you the important sentences. But further, if you want to find out sentences that are diverse enough with respect to each other, then you will use some sort of MMR, maximum marginal relevance algorithm. So you will say that, okay, sentence, if it is already similar to some sentence in the summary, I will reduce its overall score. And then I will sort the remaining sentences again and choose the sentences that are coming out to be having highest score. So lexrank you can always choose as one of the very simple and effective baseline for any of the summarization task. Although that it does not give you much flexibility in having you decide what is your criteria for importance. So how do you want to choose your important sentences? So in this lecture today, what we will see that there are some approaches that can help you, that can give you a generic framework for optimization, and then it's up to you to define your own optimization function, your own constraints, and you can keep on adding your constraint depending on your task. So we will probably discuss about one or two scenarios that how do you modify it for different tasks. So in this lecture today, so we are talking about the optimization based approaches for summarization. So for doing that, let us define it, formally define a document as containing some different textual units. And because we are talking about extractive summarization, so our textual units will be sentences. So I have some n number of sentences, so I am denoting them by T1 to Tn. Now let us say I can define what is the relevance of a textual unit Ti to be in the summary by relevance of I, rel I. Now this is a generic formulation. So I am saying I will define the relevance of each unit by rel I, but how do I compute rel I? You are free to choose your own method. So what are the different methods for computing relevance that we have discussed? One is simply by taking the weights or topic signatures in the sentence and adding and doing the average over all the weights in the sentence. That is one particular method of choosing the relevance of the ith textual unit. Then you can also run your lexrank algorithm and find out the relevance as the PageRank value of that sentence. But suppose you want to use some different criteria for relevance, so you are free to do that. So your relevance criteria might be, okay, how many named entities are involved in this sentence. That can be your criteria, and then you can accordingly define your relevance. So you can define your relevance, then you have to also define what is the redundancy between any two textual units. So that is how much they are redundant to each other. And why we are doing that? Because in the final summary that we obtain, we do not want multiple sentences that are conveying the same information. So remember, in summarization the idea is that I want to get as much information as possible within the minimum possible space. So I always have a space crunch. So I want to fit as much information as possible. So you want to remove redundant sentences. So that is another function that you have to obtain. Now the redundancy between two textual units, again you can define it by simply taking the cosine similarity of them, how similar they are, or you can also define it by some other methods like how much apart they are in the document. Are they very near? Are they very far apart? It can also depend on many different criteria like do they talk about the same sort of entities and many other things. So once you have done that, and let us say we define what is the length of the textual unit, that is simply the number of words that are there in that textual unit. Now once we have all these definitions, what will be my optimization criteria so for choosing the summary? So when I talk about summary, so in all these systems I will generally have a upper limit on the summary. So I say okay, I want a summary of length k, and k will be roughly 100 or 200 at most, depending on your input document. So you want a summary of length k. So what should be an optimization criteria? Now optimization criteria should be, so from all these Tn units, select a subset such that the score of the summary is maximized. And how do you define the score of the summary? A summary will have a subset of texture units. So score could be summation over the relevancy scores of all these units that you have taken in the summary minus what is the redundancy between any two units. So that will be all pair redundancy score. So relevancy score of all the units in the summary minus redundancy score of all the pairs in the summary. That will be your optimization function, and you want to select a subset such that it maximizes this score. So I can say that what is my inference problem? I want to select a subset S of texture units from D. So D is my whole document containing T1 to Tn, such that summary score of S, you can define it as small s of the set capital S, is maximized. And how do I define the summary score of a subset? So as I said, I will take all the texture units there, get their relevancy scores, sum over that, summation over relevance of I for all the units Ti in S, minus summation over redundancy score of any two units I and j that I am taking in the summary, and that I will sum over all the pairs. But I do not want to sum over, I do not want to repeat a pair, so I will put some ordering, say I has to be less than j, and they can be the order in which they occur in the document. So I have this Ti Tj in S, I is less than j, and I am getting their redundancy score. So what is this objective function trying to achieve? Maximum relevance within the set with the minimum redundancy. So total score is defined like that. Now, and then what is the constraint for doing that? The length of all the texture units that you are taking the summary, Li in all the Ti in S, should be less than equal to k. That is your constraint. And so yeah, capital K denotes the maximum length of the summary. So now you have a constraint and you have an optimization function. Now question is that how do you achieve this optimization? How do you maximize this particular objective function? Now in the case of MMR, we were using a sort of greedy approach for doing that. So a greedy approach is always a solution. So how would you use a greedy approach? So you have some n texture units, and so you have also computed the relevancy scores. So you have units T1, T2 up to Tn, and you have computed the relevancy score rel1, rel2 up to rel n. Okay, and as we have discussed, this can be computed by many different ways. So let's not worry about that. Now once you have computed all that, you want to maximize your objective function, that is, and you have also computed your redundancy score of ij between every two units. So your objective function is, I want a summary such that summation of relevance is minus redundancy between all the pairs is highest. So what you will do in a greedy approach, you will first sort these, sort as per the relevance, and you get some final sorting order, and let us say that order is T1 to Tn. Okay, T1 has the highest relevance and Tn has the lowest relevance. So what will be a greedy approach? I will say okay, take T1 in my summary already. Okay, so now T1 is there in the summary because it has the highest relevance. Now the next unit will not be directly T2. So we will say okay, among all the possible units, which unit I can add to my summary such that the score is maximized. So I am doing it one by one. So what is the score? Summation over relevance of T1 plus T2 minus redundancy of T1 T2. So that will be the score for adding T2. Okay, so you will add T2 to the summary. So this is your summary, you will add T2, and now this call it your S prime, and then compute your objective function for S prime, okay, with T2. Then you will, instead of T2, you will put T3 and compute it, and so on you will do for all the Tn. And finally you will have all different summaries, all the scores, take the one that is having the maximum score. So suppose sum T3 gets you the maximum score, so this gets into my summary. Now again from the remaining units, again keep on adding one by one to the one at a time to the summary and see which one is giving you the highest score. Take the one. And you will stop whenever you have achieved the desired length of your summary. That will be your final summary. So it's a greedy method. So what we are doing? So I'm sorting my all the textual units in my documents as that relevance of ith unit is greater than relevance of I plus 1th unit for all Ti. So you'll get a score T1 to Tn. They are in the sorted order. Then what do? You take the first unit in your summary. Then while you have not achieved the desired length of summary, so for this loop you will take each sentence that is remaining, each unit that is remaining, put that in your summary as union Tj and compute the score and get the Rmax over all Tj's. Okay, and that will be the one that you will include in your summary, whichever gives the highest score. And then you keep on doing that until you have achieved the desired length of your summary. And this is a very generic approach. You have to define your own relevance score, redundancy score, and then you can apply this algorithm to obtain a summary such that it has the highest relevance but minimum redundancy. So you achieve both relevance and diversity at the same time by using this approach. Now we are saying that this is a greedy approach. Okay, why is this a greedy approach? You are picking you're not going to an optimal solution. You are taking a greedy approach that say, okay, it's near optimal solution. It may not be an optimal solution. I am always choosing T1, but it might happen that in my optimal solution I do not have T1 because T1 is similar to many other sentences. This can always happen. So this does not guarantee an optimal solution, but this is good enough if you want a decent solution. There are other approaches where you can use dynamic programming algorithm to find out, okay, what is the best way I can fill up my length k such that this is maximized. Of course, if you try out all possibilities, it might be exponential in nature, but you can always use dynamic programming so that you are storing some results. What is the best way of achieving a summary of length 5, 10, 15 and so on, and then use that for any higher length. So that is another approach. So what we will discuss instead is an approach that is again very generic, and there, although we have started with some optimization function and some constraint, you are free to choose your own optimization function and also your constraint, and still this will give you an optimal solution. And this approach is called integer linear programming. So there you are trying to optimize some objective function with respect to certain constraints, and you are getting some integer solutions for your different parameters, that such that they maximize the objective function. So let us first see what is that. So we will talk about how to use the integer linear programming for summarization. So this is like a greedy algorithm. So greedy algorithm that we discussed in the previous slide, it gives me an approximate solution. So now, ILP will help you to get an exact solution, that is the optimal value for this objective function. Now ILP is like a constraint satisfaction problem. So you define the various constraints, and based on those constraints you are trying to optimize your objective function. So important thing is that all your constraints should be satisfied. Now your constraint will be such that are needed for your summarization. For example, what is one very simple constraint that you will always put? That summation over all the units that you have selected has to be less than or equal to k, where k is the desired length. That is one constraint that you will always put. Plus you might have some other constraints based on your task. We will discuss that once we will give the basic approach. Now, so one good thing about ILP is that there are many different solvers on the web, and you can take any of those, and in the format that they have described, you will put your objective function and constraints, and they will give you the solution based on that. So initially, to understand ILP, we can define our constraints, and based on only the relevancy and redundancy. So the two things that we talked about in the previous slide also. So let's define our constraint objective function based on that, and then we will see what will be the form of the ILP. So here, this is my objective function. So now what we are doing? So again, suppose that we have different textual units T1 to Tn. Now I also have defined their relevance and redundancy. So for now, again, like in the previous case, assume that you know how to compute the relevance and how to compute the redundancy between two different units. So once you have defined all that, now you are saying I want to maximize some function summation alpha I rel I minus summation I. So this is an ordering to ensure that you are doing it only once, alpha ij redundancy of ij. Now one thing you will notice that we are not, so in the earlier case we are taking a subset, we are saying I will take a subset and for that subset I will maximize this. Here we are not taking the subset, but instead what do we have here? We have some different parameters alpha I and alpha ij. Now what are these parameters? So alpha I is a simple indicator that tells whether the ith unit is included in the summary or not. Okay, so I am saying alpha I summation alpha I rel I. So alpha I will indicate whether the ith unit is in the summary or not. So alpha I should have a value of either 0 and 1, 0 or 1, or it can take only one of these values. And similarly alpha ij redundancy of ij. Alpha ij again can take a value only between 0 and only 0 or 1. Now what do these parameters alpha I and alpha ij indicate? 0 means this is not in the summary, 1 means it is in the summary. So whenever it is 1, you are taking the relevance, 0 it is not being counted. Alpha ij will be 1 whenever I and j both are in the summary, and so that means if I and j both are in the summary, you have to subtract their redundancy score. So now, you are trying to find a solution such that this is maximized. So now you should put certain constraints. So for example, if you do not put a constraint, I can always find a solution where alpha I is equal to 1 for all I, alpha ij is equal to 0 for all ij. I can always put some solution like that. But you will immediately say, okay, this does not make sense because you are not subtracting the redundancy of the sentences. One thing. Second, you are taking all the sentences in the summary. So what is the point of the summary? You are taking the whole document. So this optimization function is not sufficient until you add the constraints. So what are the constraints you will add? Okay, so this is the optimization function. And what will be the constraints? So constraints, the first one that will come to your mind is that the length of the summary has to be less than or equal to k. So how will you put that constraint? You see so by this approach you want to find the optimal solution for all these alpha i's and alpha ij's. They can take values between 0 or 1. Okay, what is the optimal values? So you will put some constraints. So one constraint will be summation alpha I li less than or equal to k. Li is the length of the ith texture unit. This is less than or equal to k. That will be the constraint that will immediately say, okay, this kind of solution is not acceptable. But again, you can find a solution where some alpha i's are 1, but all the alpha ij's are 0. So you do not want that. You want that whenever alpha I and alpha j are 1, alpha ij has to be 1. So you need some more constraint for that. So what are the constraints we will put here? So we will say, okay, so whenever and also you do not want alpha ij to be 1 and alpha I to be 0. It cannot happen. So all these things, how do we put together in the constraint? Let us see. So we are saying all the alpha I, alpha j are either 0 or 1. Okay, that's the first thing that we said. And summation I, alpha I, li is less than or equal to k. Then the next two constraints are alpha ij minus alpha I is less than or equal to 0. So alpha ij minus alpha I less than or equal to 0. What does that mean? They can take values 0 or 1. So what are the possible values? Both can be 1. This is allowed, right? Alpha is 1, alpha ij is 1 is allowed. Both are 0, that is allowed. But what is not allowed? So and also if alpha I is equal to 1, alpha j is equal to 0, alpha ij is equal to 0, that is also fine, this will be -1. What is not allowed? Alpha ij is equal to 1, alpha is equal to 0, this is not allowed, okay, because then this will be 1. And why it is not allowed? What it is saying is that you are not including the ith unit, but the redundancy between I and j, and this is not possible. This you can pick only when alpha is equal to 1. So this is a constraint like that. Similarly, you have a constraint now alpha ij minus alpha j less than equal to 0, and that you can understand in the same manner. Now what is the third constraint that you are putting? That is alpha I plus alpha j minus alpha ij is less than equal to 1. Now what is this saying? So this can take all the values except a value of 2. Okay. Now when will this take a value of 2? So you can see that it cannot take a value of larger than 2, because it can be at most 1, it can be at least 0. So maximum value is 2, and it is allowed to take values up to 1. So what happens when it takes a value of 2? That means it is 1, it is 1, it is 0. Okay. But it ensures that whenever they are 1, you put it as 1. You are taking it as 1. Okay. So this constraint helps you in that you cannot put alpha ij is equal to 0 whenever alpha I and alpha j are both 1. So together these 5 constraints will actually give you the same sort of objective function that you were doing earlier, but now in the terms of integer linear programming. So now your integers alpha I or all the alpha i's and alpha ij you have to choose such that these objective function is maximized and the constraints are satisfied, and then you can run your ILP solver to actually obtain these solutions. Now what is good about this approach is that it is very generic enough. So depending on your task, you can define what is your objective function and what are your constraints. So for example, here we took very simple constraints independent of your task. But suppose in your task, so for example, you are doing a summary from a say research article, and research article has various sections, section 1, section 2 and section up to section 5. Okay. And now suppose you want to put a constraint that in my summary I want at least one sentence from each section. Okay. So you can easily put that constraint in your ILP. So you can define what is the section information for each of the unit, and then say for each section information you will have at least one unit in your final solution. So that is a constraint that you can add. Similarly, suppose you have some sort of data where that is temporal. So suppose news articles, and you have over various days. So day 1, day 2, day n. So this generally happens when you are doing some sort of timeline summarization. So you have about an event, you have various articles in a timeline, and you are trying to summarize that. So there you want to put a constraint that I want, if a similar kind of information is there in two different time points, I want the later time point information. Or you can say that I want more information from the later time point than the previous time point. Again, you can put them in as your constraints. You define, like you defined your length, you can define the time period, and you can say, okay, certain time period I want more than the previous time period. This can also add as your constraint. Then you can also change your objective function. So here we said, okay, we will sum over all the relevance score of the texture units. But suppose you define, okay, I want to put some weight to the importance to the different say like sections or days. So you can multiply the relevance score by certain weight. Okay. So this can be the importance weight of different days. So this can also come in your objective function. So like that, this is very generic approach where you can keep on changing your objective function. So you can also maximize multiple things together, and you can keep on adding your constraints depending on your task, and you will still be able to find the solution using ILP. Now, so once we have done this, so we have talked about different methods for doing summarization, a graph based approach and an optimization based approach. So then, so what we will be discussing in summarization? Once we have selected the important sentences, the next step will be how do I order these sentences. Now, ordering might also be some sort of a heuristic approach. So what is the simplest approach that you will take? So once you have found the sentences from the document, you will order them in the same way in which they occur in the document. Okay. So although their relevance might be that the sentence that is at the bottom has the highest relevance, but you will take the sentence that is coming first in the document as the first sentence, and so on. So the order in which they occur in the document, you will provide that set. But there are some other approaches also, and they are called like you want to optimize the coherence of the summary, so that it becomes more readable. Okay. So what is one possible way? So you do not give very drastically different sentences together. So we'll say, okay, I'll try to put them together in an order such that the two sentences that are close enough are similar to each other. So that is one possibility. Or you can say that they talk about the same sort of named entities or events. So that is another criteria for ordering. So either you can list the sentences in the order they appear in the document. It's also called the chronological ordering. And you can optimize the coherence, that is choose ordering that make the neighboring sentences similar by cosine similarity, or choose ordering in which the neighboring sentences discuss the same sort of entity. And you can also do topical ordering. So you find out in document what topics occur in what order, and accordingly you put the sentences. Sentences belong to this first topic will come first, and so on. That is another possibility. So once we do that, another approach, another step could be that, okay, I want to further reduce some sort of redundancy from there, and that can be in the way we write. Okay. So let us see what are the different ways in which you can simplify. So for simplification of sentences, so simplification is important because by simplifying sentences you can get more space into your final summary. So some sentences that contain some information that is not important, you can remove that, and that is like not a very easy step. So what you will do, you will parse the sentences and remove certain specific clauses and phrases, like for example initial adverbials. So many sentences start with for example, on the other hand, as a matter of fact, at this point, etc. All these are not important to convey the information, and you can remove these initial adverbials. Then some prepositional phrases that do not contain the named entities can also be removed. So like here, the commercial fishing restriction in Washington will not be lifted unless the salmon population increases to a sustainable number. To a sustainable number is a prepositional phrase, and this may not be very important to convey the information here, because it does not contain any named entity. So you can also remove this. Then you can also remove the attribution clauses, like rebels agreed to talk with government officials, international observers said Tuesday. Okay. So this attribution to something, this may not be important, so you can remove this also from your summary. Then certain appositives can also be removed, like Rajan, 28, an artist who was living at the time in Philadelphia, found the inspiration in the back of city magazines. So the appositive here is an artist who was living at the time in Philadelphia, and this may not be important to convey the information. So like that, you can also define many such rules. These rules can be again given manually to the system, and you can also learn these rules. If you have some sort of data that says, okay, what is the original sentence and how did some human simplify that. So from there you try to learn the rules, that what kind of nodes in my parse tree can be removed and how I can simplify my sentences. That is also possible. So we discussed 2-3 different approaches for summarization, and how can you do some final polishing and post processing once you get the sentences to fit in a much smaller space. And as such, there are many different approaches for summarization. You can always use these as your baselines, but you can also explore the other methods. So in the next lecture, we will briefly discuss that once you have done the summarization, how do you go about evaluating your system summary. So, you are getting some summary and how good is that. So, what is the different methods. We will talk about one specific method for that.